equations, two things we don't know. Systems of equations, they seem hard although we got three ways to solve them. You could first try to graph them. Graph one of them on a coordinate plane today, then graph the next one. Be careful, don't go astray. Their solutions are the points where our equations touch. Write down the ordered pairs you've done that didn't hurt so much. That's how we solve. That's how we solve. Systems of equations, two things we don't know. Systems of equations, they seem hard although we got three ways to solve them. You like the next one, eliminations, add equations to cancel off x or y. You can multiply first if you think that it will apply. Find the variable and you are about halfway done. Plug it in to find the other. Algebra is super fun. That's how we solve. That's how we solve. Systems of equations, two things we don't know. Systems of equations, they seem hard although we got three ways to solve them. You like the next one, substitution. You can solve for y written in terms of x. Plug that in the other equation that we have next. I will leave the rest as the viewer's exercise. You'll get the right answer and you won't believe your eyes.
Okay, 2.1, solving systems of equations. Three ways to solve them, just like the video says. We have graphically, substitution, and elimination. We're going to take graphically first, as we just saw in the video. The video mentioned about just graphing the lines and seeing where those two lines intersect. So that's exactly what we're going to do here for the first example, first type of way to solve systems of linear equations. So the example we have here is solve the system graphically. We have two equations. We have 3x minus 2y equals -6. And we have x plus y equals -2. So we need to get y by itself, okay, in both of these equations. We'll do the top one first. So getting y by itself there, we have -2y equals -3x minus 6. So we subtracted the 3x over. We'll now divide by -2. So we get y equals 3/2 x plus 3. And then we'll just graph this. Now, in order to get an accurate graph, in order to get an actual accurate solution, you must use graphing paper and a straight edge. Okay, we can't just freehand draw this one. We'll never get the correct answer if we do. So I have a graph paper here in front of us, and I'm going to use a straight edge function that's built into this program to make sure we have a very accurate graph. So we'll start at plus 3, so on the y-axis, and then we'll use the slope, as we've done before, to get another point. So we're going to go up 3 and 2 to the right. Okay, so since you have a straight edge and I have a straight edge ability to draw, I'm just going to go ahead and connect those two up with a straight line. Okay. Now we just have to get y by itself in the second equation and see where those two come together. Okay, so getting y by itself in the second equation, we have y equals negative x minus 2. All right, so we'll start at negative 2. We use the slope, down 1, right 1. And again, if you have a straight edge, we can draw a very, very, very straight line here. Now, this could be interesting. Let's see how this turns out. I think that worked out quite well. You'll see the two run into each other. Now, the question is where are they running into each other? I personally think it looks like, to me, looks like they're running into each other at negative 2, 0. Now, notice the words that I used to determine that. Looks like, I think, there's a lot of guessing here. Okay, now one thing you could do to help out is you could continue with the slope. I'm going to go with the blue dots here. If I went down 3 and over 2, that blue dot actually would be on that point where they intersect. If I went down 3 and over 2 again, you would continue to see the points. And if we went with the red dots and put them, followed the slope with those, you would see also that the red and blue dot actually end up on the exact same point, negative 2, 0. But if they don't actually end up on top of each other using the slope, it's your best guess. It could be a decimal, it could be a fraction, so it doesn't have to be exactly integer answers every time. In this case, though, it looks like we are getting negative 2, 0. The only way to truly know what the answer actually is to use the exact science of algebra. Right, now, when you are doing systems, there's going to be 3 possible solutions. The one we just saw and the one that you saw in the video is situation number 1. Now, the math vocabulary words that we use for that is consistent and independent. That means we have exactly one solution. Another possibility is if we have infinitely many solutions, or we happen to graph the same line. So I believe we refer to that as coinciding when we talked about slope. And two lines that are coinciding are when you've got y by itself, you end up with the exact same equation. So if we graph that exact same equation, we'd have just a line on top of itself, meaning that there is infinitely many solutions to that system. And then the last is another situation that we ran into, and that's no solution because parallel lines would never hit each other. So if we find out that we have parallel lines and they are in a system, we know that there is no solution. We call that inconsistent in mathematics. Right, on to the next way to solve them. That's substitution. Okay, so what we're going to do with substitution is we're going to isolate one of the variables. So you want to take a look at the equations and decide which one has a variable that'd be easy to solve for. Now, personally, I think this equation looks like it'd be really easy to solve for x, because all we'd have to do is add y over. So we get x equals y plus 2. All the other possibilities, getting x by itself in the first one would require multiple steps, same for the y, and even same for the y for the second. We would have to do 2 steps instead of just 1. So let's, once you have y or x by itself, doesn't matter which one, then we're going to take that, we're going to plug it into the other equation, so in this case the first, it's going to go into the first for x. So x right here is going to get replaced with whatever is x is equal to. So we're going to replace it with y plus 2. So we get 2 times the quantity, y plus 2, plus 3y equals 8. Now that we have all y's in the equation, we can solve for that y. We distribute the 2. Combine like terms, so 3y plus 2y is 5y. I'm going to go ahead and subtract the 4 over while I'm here and get y by itself. So divide by 5, we get 4/5. In order to find x, we're going to plug y back in, where you see what x is equal to. So we get 4/5 plus 2. That's 2 and 4/5. That's going to be 10, 14/5. Okay, so what is our solution? Well, we have an x, and we have a y, so we have a single point. Remember, one of the possible answers is exactly one solution, and that's a point. Okay, that's what solves a system of linear equations. The last method that we are going to look at is elimination method. And elimination does exactly what it sounds like it's going to do. You are going to eliminate one of the variables. Now, you want to pick the variable that's going to be the easiest one to work with, because often you're going to have to multiply by something in order to make the coefficients in front of that variable the same. Once the coefficients in front of the variable are the same, then we can eliminate. So I see the x's here are 1.5 and 2.5. Boy, decimals aren't always the easiest to work with. 2 and 5 is pretty straightforward. If I wanted to make them the same, I would just multiply the first equation by 5 and the second by 2, and I think we'd be in good shape. So let's go ahead and do that. I think we're going to eliminate y. So we're going to multiply the first by 5 and the second by 2. Okay, so if we take 1.5 times 5, we end up with 7.5. And 2 times 5 is 10. And 20 times 5 is 100. Okay, if we take 2.5 times 2, we get 5x. 2 times 5 is negative 10y. Equals 2 times negative 25, negative 50. Okay, so as you can see here, we have the y variable has the same coefficient in front of it. Now, since the signs are different, we can simply just add these together, and y will go away. So when I take 7.5 plus 5, I end up with 12.5x. I take plus 10y and add that to negative 10y, that's going to become 0, so y has been eliminated, it's gone. And 100 minus 50 is 50. Okay, if we take 50 and we divide that by 12.5, we end up with 4. Well, once you have x or y, in this case x, we'll take that and plug it back into either equation, it doesn't matter which one. We'll go ahead and plug it back into the first one. Those numbers seem a little bit smaller. So we're going to end up with 1.5 times 4 plus 2y equals 20. And if we take 4 times 1.5, we end up with 6 plus 2y equals 20. Okay, getting y by itself, first we would subtract the 6 over, so it ends up giving us 14. Divide both sides by 2, we get 7. So our single solution is 4, 7. Okay, so I think that finishes up our 3 ways to solve them: graphically, elimination, and substitution. I hope you enjoyed the lesson. A little more video here to watch.
Because you solve systems of equations to we don't know. Systems of equations, two things we now know. Systems of equations, two things we now know. We now know. Two things 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 we now know.
Systems of equations.